In this video I'm going to explain the chamfer and countersink screen for the drilling tasks. You can select the screen by pressing the option button. In this screen you can select a chamfer tool. You can edit the tool and select it by pressing select. The chamfer tool table is shared among all drilling tasks, so you only need to set up once. Before we can use a tool, it has to be calibrated. We need two calibration points. A calibration point is a calibration diameter and a calibration depth. The calibration depth is how far this tool will sink in that hole. We can measure this depth using a mill or a drill. We can use the top slide, or we can use the repeat task to find the depth. Before we do anything, we have to set the tool length of this chamfer bit. I prefer using the probe, but you can also set the tool length manually. So we leave this screen and probe this tool. Now the tool length is set. I can press the go to start position button. This moves the tool to the 0 position. I can now measure the depth using the top slide. I find 0.45 first value, 0.42 second value, 0.42 third value. So the average is 0.43 millimeters. We move the tool back to the home position. The second way to measure the depth is using a repeat task. I set the next drilling depth to 0.1 millimeters. I set a slow feed rate. I reset total cut. I will start the repeat, and as soon as the chamfer tool touches the edge of the hole, I will stop the repeat. So I turn on the spindle and press repeat. I have a total cutting depth of 0.4 millimeters, but that was too much. The previous cut was at 0.3 millimeters, that was too shallow. So the actual depth shall be between those two values, about 0.35 millimeters. So there's a difference in what we found using the top slide and using the repeat tasks. I prefer using the repeat task value. So I set my calibration point to 0.35 millimeters. So we select the option screen, we set the calibration diameter to 3 millimeters, and the calibration depth to 0.35 millimeters. The tool angle of this countersink tool is 90 degrees, so I can calculate the second calibration point. We add 2 millimeters to the diameter and 1 millimeter to the depth. If you using inch values, it is the same. The tool angle is calculated to 90 degrees. We have found a minimum diameter of 2.3 millimeters for this tool, so lower than 2.3 you can't go. Next we have to set the countersink depth. According to the datasheet, this chamfer tool has a outer diameter of 6.3 millimeters. When I change the chamfer diameter, the chamfer is calculated, and for this chamfer you need a cutting depth of 2 millimeters. So the countersink depth will be 2 millimeters. Now the tool is calibrated, we can chamfer the hole. I want a shallow chamfer of 0.3 millimeters, and when I press the set chamfer depth, the drill depth is set to 0.65 millimeters, total cut is reset, the drill tool is set to a chamfer tool, and we can now chamfer this hole. I will chamfer at 20 millimeters a minute. So when I press AutoCAD, the hole should be chamfered. The hole is chamfered. We go back to the option screen, and now I select set countersink depth. The cutting depth is set to 2 millimeters, the total cut is reset, and I can now countersink this hole. I do it at 5 millimeters a minute and 250 RPM. So we press AutoCAD. I don't know if you can see it on camera, but there was a lot of chatter. We test the countersink. And that looks okay. That's it. Thank you for watching.